This is Lecture 2, Chapter 4. In this session, I shall tell you about number 1. Why does carbon form such a large number of compounds? Number 2. Saturated and unsaturated carbon compounds. And number 3. Structural isomers. That means straight chain, branched and ring or cyclic carbon compounds. You studied that the elements having 8 electrons in the outermost cell of their atoms are all noble gases, and those are very little reactive. Other atoms that have more than one cell react to complete the octet. Hydrogen has only one cell. First cell cannot accommodate more than 2 electrons. On getting 1 electron, hydrogen atom gets stabilized. The property of atoms of an element to bond with atoms of the same element in large numbers is called catenation. Carbon is the smallest atom that has 4 electrons in its outermost or valence cell. It means valence cell is half filled. That makes it very difficult to lose 4 electrons or gain 4 electrons to complete its octet. It means it has tetravalency. That is why it shares 4 electrons with other atoms. This sharing is done with other carbon atoms or atoms of other elements. This type of bonding in which electrons are shared by the combining atoms is called covalent bonding. Small size makes it possible for the positive nucleus to hold negatively charged electrons strongly. Carbon-carbon bonding is strong enough to make very large chains possible. That is why carbon shows catenation more than any other element. The number of compounds formed by hydrogen and carbon is more in number than the compounds formed by all other elements together. Carbon can form double and triple bonds also. Next element after carbon that has 4 electrons in the valence cell is silicon. Silicon also shows catenation, but not to the extent of carbon because of its larger size. Next, I discuss saturated and unsaturated carbon compounds. In carbon compounds, if all carbon-carbon bonds are single, then the compound is saturated one. If any carbon-carbon bond is double or triple, then that compound is unsaturated. For example, C3H8. You see here the structure. Here all carbon-carbon bonds are single. Therefore, it is a saturated hydrocarbon. But in C3H6, you see the structure CH2, CH and CH3. Here, one carbon-carbon bond is double. The electron dot structure of these are, you look here, this is the electron dot structure of these compounds. Hydrocarbons are the compounds of carbon and hydrogen. If in a compound the number of carbon atom is 1 having 4 hydrogen in it, then it is methane. The formula is Ch-4 and the structure is, you can see here, carbon bonded with 4 hydrogen atoms. All are single bonds obviously. Next hydrocarbon is with 2 carbon atoms. Its name is ethane if it combines only with the hydrogen. Here in ethane, carbon-carbon bonding is single. So ethane is a saturated hydrocarbon. If carbon-carbon double bond is there, then it is an unsaturated one. Here you can see with 3 carbon with 1 double bond and 1 single bond, then it is ethene. Next, I discuss about structural isomers. You look at the following compounds. The first hydrocarbon is methane with 1 carbon atom bonded with 4 hydrogen atoms. No other structure is possible in methane. Next is ethane, 2 carbon atoms bonded with 6 hydrogen atoms. You can see here. In ethene also no other structure is possible. Next comes propane, 3 carbon atoms and 8 hydrogen atoms. Formula is C3H8. It also cannot have any other chain structure. Next is butane. Its chemical formula is C4H10. One straight chain structure is CH3, CH2, CH2, CH3. It can have another chain structure. Such compounds having same molecular formula but different structures are called structural isomers. About other isomers you will study in higher classes. Next, It is pentane. Chemical formula is C5H12 and one of the chain structure is CS3, CS2, 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 CS3. Next is hexene with 6 carbon atoms. Its chemical formula is C6H14 and one of the structural formula is CS3, CS2, 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 CS3. All such hydrocarbons in which carbon-carbon bond is single are saturated hydrocarbons, and this series of hydrocarbons I have just discussed are called alkanes. The chemical formula of hexene is C6H14. Carbon compounds can have cyclic structures too. For example, this hexene can have cyclic structure also, and that is called cyclohexene. The structural formula of cyclohexene is, you can see here, CS2, 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 CS2 and CS2, all bonded in a closed ring, and its chemical formula is C6H12. If in this alternate bonds are double, then the chemical formula comes to C6H6 and the compound so formed is called benzene. So here you can see the benzene structure. Unsaturated hydrocarbons that have one or more than one double bond are called alkenes, and the hydrocarbons that have one or more than one triple bond are called alkynes. In the end, let us revise in brief what we have learned today. First, we learned that carbon forms a very large number of compounds. Hydrogen and carbon together form a huge number of compounds. This is because of the property of carbon atoms to form very long chains by carbon-carbon bonding. This property is called catenation. Next, at number 2, we studied that carbon forms maximum compounds with the hydrogen, and these are called hydrocarbons. If all carbon-carbon bonds are single, then no hydrogen atom or any other group can be added to such a compound, and such a hydrocarbon is called saturated hydrocarbon. If, on the other hand, one or more than one carbon-carbon bond is double or triple in the compound, then hydrogen or other group can be added to such a compound. Therefore, such a hydrocarbon is called unsaturated hydrocarbon or unsaturated carbon compound. At number 3, we studied straight, branched and cyclic carbon compounds, and we studied structural isomers. Same chemical formula compounds can have different structures. Such compounds are called structural isomers. The structural isomers can be straight chain, branched or cyclic carbon compounds. Now here is a question for you. Why do carbon and hydrogen form such a large number of compounds? That's it, today's lecture. Goodbye.